Hi there. We've been working a lot with factors, and we've just added to that multiples. So that sort of begs the question, what are factors, what are multiples, and how do we find them? So let's start off. Factors are just the numbers in a multiplication problem. So that means if we've got 3 times 7 equals 21, 3 and the 7 are my factors. Now, the question is, what do you call this? That is called a product. The clue that I always give to the kids is, what am I producing when I do 3 times 7? And then we get our 21. But we've got this new word, multiple. And the question is, where does multiple come from? Well, I always give the kids a sentence to sort of analyze, and it looks like this. 21 is the third multiple of 7. And obviously, it's not literally that sentence. It's whatever math problem they give me to work with, I make this sentence using that. The point we need to know is that 21 right here is the multiple. So products are synonyms for multiples. Why do we call it a second name? That ties in to the fact we said it's the third multiple. A multiple is essentially the list of products that we can make when we multiply our starting number. So if we think of it as the products made by multiplying our number, we start with 7. I don't want kids to think of it as skip counting, because then they lose the idea that these come in an order, right? The third multiple is 21 because it's going to be the third in our list. We start off. Normally we'll do this mentally, but let's say it's times 1. Our first multiple is 7. Our second multiple is 14. Our third multiple is 21. Our fourth multiple is 28, and so on. That can go on to infinity. The main concept here is that multiples are when we take our starting number and multiply it and make a product. Our factors are the numbers that are inside. Now, what skill are we doing with these? In terms of factors, usually what we're doing is looking for the factors of a number. The real-world applications will hit more in problem solving. This is just the nuts and bolts of how to find them. I find the easiest method for finding them is to do an organized list, and I normally organize it by making a T-chart. So this is a T-chart to find factors. If we go back to our last video, we were going to start with a 32. You put the 32 at the top, and it's a T-chart because literally you're just making a T-shape. We try to keep ourselves organized by starting with a number and then counting up. We always start with 1 because 1 always works. Even prime numbers, which we've talked about before, are just 1 times the number itself. In this case, every pair of numbers is essentially a multiplication problem. These are the factors that make my 32. After I've got my 1, I check to see if anything else works. And from here, a lot of people just brainstorm math problems and remember math facts. If we don't want to miss anything, especially something that's not a typical math fact, we actually want to use those rules of divisibility, getting my magic paper from before, those rules of divisibility, to try and check every single number in order. So the next number I'm going to check is a 2. Since our rule was works with even numbers, we know it's going to work, and now we've got to figure out what it was. Using a multiplication chart, using division, using that little technique where we say 2 times what equals the tens place, 2 times what equals the ones place. Whatever you want to use, you find out it's 2 times 16. The point is, you know to look for the 16 because you know something works with the 2. Next thing we check is a 3. Instead of sitting there and listing our math facts, we use that little trick from before. 3 plus 2 is 5. 3 doesn't work with a 5 because 3 times 1 is 3, 3 times 2 is 6. We don't have a 5, so 3 is not going to work. Next thing we check is a 4. There is a rule for a 4. I didn't go over it because the rule for 4 doesn't really kick in until you're over a 3-digit number. But in any case, this one does work with a 4. 4 times 8. This is where checking in a multiplication chart or using your math facts is important. Next, we check a 5. Doesn't have a 5, doesn't have a 0. Next, we check a 6. Our rule for that is needing a 2 and a 3. We've got the 2, don't have a 3. 6 doesn't work. Check our 7. No good rule that I know for 7s. We check our math facts. 7 times 4 is 28. 7 times 5 is 35. We missed our 32. 7 doesn't work. Next, we check our 8. Hey, we've already gotten 8. Therefore, we are finished. We've got a couple of rules for knowing when we're done. The first rule is if the number we're checking we already have, we know we're finished. The second time we have that rule would work with something like 36. I'm going to do 1 and 36. It's even, so 2 works. And I use my whatever method to figure out it's an 18. I check my 3. 3 plus 6 is a 9. 3 works with a 9, therefore it works with 36. Now I've got to figure out what. Hopefully we use our multiplication charts or division to find out 3 times 12. Next we check our 4. 4 works with 36 times 9. 5 works with a 5 or a 0, doesn't work here. 6, I've got a 2, I've got a 3, therefore 6 works. 6 times 6. Got the same number twice, so I am done. The next thing that I'd want to check is a time when we have 2 prime numbers. So for instance, let's say I was doing 44. The first thing I have is 1 times 44. Go up, I now have a 2. This is even, so 2 works. 2 times what? 22. I check a 3. 4 plus 4 is 8. 3 doesn't work with an 8. Therefore, 3 doesn't work with a 44. Now I do my 4. Hopefully we recognize double digits as being an 11. That was a bad example because that's 4 times 11. I don't know what I was thinking. Point is here, we check 5. Doesn't work. Check 6. Doesn't work. Keep on going. 11 is the last thing. That was a terrible example. Let's do 33 as an example. 1 and 33. 3 and 11. 2 doesn't work because it's odd. I've got a 3 which is prime. I've got an 11 which is prime. I don't need to check a 4 and a 5 and a 6 and a 7 and all that stuff because I've got 2 prime numbers. Therefore, I'm done. Now we need to move on to multiples. All of these were factors. I was finding the numbers in a multiplication problem. 1 times 32, 2 times 18, 3 times 11. All of those are factors making these starting numbers. This chart totally works for 44. It was just a bad example of finding 2 primes. The next thing we need to do is list multiples. This is literally just skip counting. So if I wanted to find multiples of 8, I would say 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. Times 4 is 32. Times 5 is 40. You continue that list for as long as is useful. So the question is, what makes this useful? Why bother doing it? There might be a question that says, what's the 4th multiple? Then you just say, oh, 32 is the 4th multiple. If you're smart, you notice the ordinal number of these, 1st, 2nd, 3rd, 4th, goes with the times 1, the times 2, the times 3, the times 4, and instead you just do 8 times 4 is 32.